All right, welcome to Unit 2, Part 2, or Unit 9, Part 2, Day 2. Today we're going to be focusing on not just factored form like we did yesterday, but also vertex form. And you notice we're going to be able to find the stretch factor today, which is going to involve a little bit of solving, but not too much. This is not in your notes. This is from yesterday. Just recall the three forms. Again, I'm always going to stress to you that the standard form gives us the y-intercept, which is C. This gives us the vertex of h comma k. And these two are just our roots or our zeros. All right, so each form has its purpose. All right, so the first thing we're going to do is look at a graph and find its x-intercepts, its vertex, and write an equation based on those. So the x-intercepts look like it's at -5, 0, and 2, 0. And it looks like the vertex is at, I can't tell. Let's say the vertex is at -1.5 and -12. And that 1.5 isn't going to throw us off. It's just a decimal. So if I wanted to write it in factored form, it's going to look something like this with two parentheses. X, and remember it's x minus r, root 1 and root 2. Remember it's the opposite sign from yesterday. So if it was a -5, it's really a +5. And if it was a +2, it's really a -2. And then the vertex, it looks like this graph went left 1.5 and down 12. So if I want to say it went left 1.5, I really write plus 1.5, and that's squared because it's my vertex form. And then it went down 12, so I write a -12. Again, we're not worried about whether it has a number in front yet. That's what we're going to focus on today. So first, now this is going to, instead of looking at a graph, now I'm just going to tell you the x-intercepts are at 3 and 7. It says write a possible equation. All right, so it says ignore the fact that we don't know the stretch factor. So a possible equation in factored form is going to be x minus 3 because it was really a +3, and x minus 7 because it was really a -7. And then it says graph. Now what's nice is I already have my graph down here. But on your paper, all you're going to do is look and see, all right, I'm going to sketch a graph at put a dot at +3 and a dot at +7. And again, this is where it gets tricky. It says, what's the axis of symmetry in the vertex? I'm going to just have you go to the vertex first, which is that point right there. So the vertex is 5, -4. Now we know that the axis of symmetry is just the x coordinate of the vertex, which is 5. So really the axis of symmetry, if I can draw a straight line, is going right there. Now what's nice is you can look and see that it's really just the middle of your vertex. It's kind of like the middle of your zeros. It's kind of like finding the median between 3 and 7. So if I go slash, if I put my fingers here and I go, all right, 3, 7, cross them out, and then I'm at 4 and 6, and then I plop to the middle, and you see I get right at 5. So the axis of symmetry is at x equals 5. Right, so that's just if we're doing it generically. Now we need to remember what stretch factor does. So all of these graphs have zeros at, remember it's the opposite, so +1 and -5. So I'm going to go to +1, oops, and -5. And this one's going to be just normal. Mine's not going to be perfect. It'd be a lot lower than that, but let's just pretend my U's were nice. All right, so, but then if I look at the next one, it's got the same thing, but remember that 2 in front makes the graph narrower, so it's going to be a lot skinnier. It's going to be stretched. My U's are not happening today, but, and then that last one, remember, a 1/2 in front and negative makes it wider and makes it open down. So all of these graphs have the same roots, but this number in front is really changing the overall shape of it. So now instead of just writing a generic equation saying the roots are at 3 and 7, I'm going to have to solve to figure out what that stretch factor is. And to do that, I'm going to need to use another point. All right, so we're going to go back to that example. Write an equation with a parabola of x-intercepts of 2 and -2. Now remember, this is the equation you wrote down. A times x minus r1, x minus r2. And we should just know by now that r1 and r2 aren't anything funny. They're just our x-intercepts or our roots. And this a is what we're trying to find. So when we start, we're just going to leave the a there. So it gives you the steps right here. Y equals a times. Well, if my x-intercept is at positive 2, my equation is really going to be a negative 2. And if I have another one at negative 2, I'm going to write a plus 2. Notice a is still in the equation. We don't know what it is. Now they give us this extra step. They haven't given us this before. Given the graph goes through 1, 6. Well, that's an ordered pair x comma y. So the next step I'm going to do is substitute the point 1, 6, xy in for x and y. So instead of writing y here, I'm going to write 6. And instead of writing x here, I'm going to write 1 minus 2. So if I look back at this equation up here, I replace the y with 6, and I replace both of the x's with 1. So now I can solve. So I write 6 equals a. 1 minus 2 is negative 1, and 1 plus 2 is 3. So I get 6 equals a times negative 3. Well, to solve for a, I need to divide by negative 3 because it's being multiplied. So I get a equals negative 2. So now I go back to my original equation, which was right here, and I write it out. Y equals, now I know a is negative 2 now, so I have negative 2, x minus 2, x plus 2. Now what this says to me is I have a root at positive 2 and a root at negative 2. And I also have a stretch factor of negative 2, which means it's going to open down, and that 2 is going to make it a little bit narrower than our standard graph. So here's what the graph would look like. I already have it in here. Again, roots at negative 2 and 2 are zeros. It's opening down, and it's a little bit narrower than a normal parabola. All right, so now I want you to use what you just did on this one and see if you can get through this one given the steps. I already have the steps here for you. All right, so pause the video, see how you do. All right, I have x-intercepts at 3 and 8. Again, it's opposite, so it's going to be x minus 3 and x minus 8. The a stays because I don't know what it is. Now I'm going to replace the x and the y with the value I know. So I'm going to rewrite the equation y equals a times x minus 3 and x minus 8. But I'm going to replace the y with 7 because my ordered pair that I know is 10, 7. And I'm going to replace the x's with 10. So I end up solving now. I get 7 equals a times 10 minus 3 is 7. And 10 minus 8 is 2. So I get 7 equals a times 14. And again, this is being times, so the opposite is to divide. I'm going to divide by 14. A equals 7 over 14, which is equivalent to 1/2. So I go and rewrite my equation at the very beginning. 1/2, I know a is now. My roots are still at positive 3 and positive 8. So my final answer is right here. And now I know that that 1/2 in front is making it more narrow. And so here's what my graph would look like. I'd have roots at positive 3 and positive 8. And it'd be a much wider parabola. Oops, did I say narrow earlier? The 1/2 is really making this graph wider. Remember, the smaller the number, the wider it is. The bigger the number, the narrower it is. So the 1/2 is really making it wider.